After we discuss the general case for the insert operation, it is time for us to see the full picture of the insert operation for the linked list. So as we see, in the beginning, the insert function will take two parameters. One is the data value that you want to store it, and then the other one is where you want to insert it. So now you see that the very first step of the operation is the preparation. New node. The operating system will go into the memory, reserve a new location, store that location as a new pointer, new PTR. And then we will try to put the element into the data part of whatever the new location we stored it and store that into the data part. So these two lines is for us to do the preparation. Now, this part of the code is showing you the special scenario, which indicating that if top equal to null. Try to think, what does it mean when top equals to null? It indicates that the linked list is empty. So this is basically the empty function. If top equal to null, that means there is nothing inside of the linked list. And then when we call the insert operation, that indicates we want to create the very first item in the linked list. So if that is the case and the position is equal to 0, indicating that the user or the people who try to insert knows that this is a null linked list, and we want to insert the very first item into the linked list. So this is like a double safe check if statement over here. You see that if top is equal to null and position is not equal to 0, that means it will go to the else part, indicating that it is going to be an error operation. So this is a safe check. So if it is null and position equal to 0, indicating we want to insert the very first item into the linked list. You see the code is actually very straightforward. What it tried to do is new PTR to the next part, which is the new element we reserved. The next part would be null, indicating this is the end because this is the very first item. I already have the data part over there. I'm saying that the next part is null. Now, all we need to do is make top equal to new PTR. Let's take a look at this part of the code. So you can see that on the left side is the code, and if top equal to null, this is what we have discussed. Look into this case, when top is equal to null, nothing is inside memory, so this linked list is empty. Now the next thing what we try to do is that we go into the new node, so our operating system will randomly select a location. Again, random select. So assuming in this case we select a location of A, it can possibly be any other locations, so we can move any other locations if necessary. New PTR equal to A, so we try to remember where is that new address going to be, and then we put 9, the element, into the data part. So you can see that the first three operations corresponding to this two line of the code, and then it has prepared us for the operation. Now, since the top is null, so you can see that it's empty over there, and then the insert location is 0, so it has passed 2 if statements check. We will be able to go into this 2 line of the code. So what we're going to see is that we make new PTR to the next equal to null. So you can see that this is where we have done it. So indicating it's a null, and then make top equals to the new PTR location, which is at the A position. So you can see that after the operation, the top will change from null location to the A location. That's what's happening for the insert operation when there is nothing inside of the linked list. Now you can see that since top is equal to A, we will understand that if we want to go through the linked list, we will come into this location, finding the very first item is 9, and it is null, so that's the only item that we have. That shows you what's happening when we want to insert the very first item into an empty linked list. Now let's continue looking to the second part of the code. So you can see that the second part of the code is saying basically they are the same scenario. If top is equal to null, then and position is equal to 0, then we do this, which is what we have just seen. So else indicating if top is not equal to null. However, the position is specified as 0, indicating we want to insert to the very first location. So at this time, at this scenario, indicating that the linked list is already exists. There are already several items over there, and we want to insert something into the very first location. So you can see the code is actually almost identical, and in fact, they are identical to each other. So you can see that new PTR, if that's the case, the new elements that we just created, the next part will equal to whatever top points at. And then make top equal to the new locations that we are looking at. So we can form the link. You can see that the two lines of the code are almost identical. What I'm trying to say is that the only difference is that new PTR to the next equal to null for this scenario, and new PTR equal to next equal to top for this scenario. And in fact, this null is actually top as well. So we can totally change this new PTR to the next equals to top, top equal to new PTR to the next equal to top, top equal to new PTR. The two lines can be identical. The reason I make it a little bit slightly different is because I want to make sure you understand the differences between the two, so that both of them are inserting the items into the very first location. For the upper example, it's inserting into an empty one. And the second example is inserting to something that's already there. Let's take a look of the code, and then we look into the examples I provide. So you can see that on this part of the code, this is where we're going to focus now. So saying that the inside of the memory space, top equal to A, and then the next location is at address of 2, the next item is 17, the next address is 7, so we will be able to go through the whole linked list scenario. And now saying that we want to insert a new item, element value is 30, at the index location of 0, so that's going to indicating I want to insert 30 to the very first location. So if we look into the code, when we try to do the insert operation, first of all, you will try to have the new node. So you will look in here, reserve a new available space. So that's 4. The reason I'm saying this available space is indicating that there's nothing inside of the memory space. So the space can be chosen as 1, 3, 4, 5, 8, 9, and B. If the operating system randomly choose one of the locations that already have items over there, then that's not going to be a valid location. And therefore, assuming that we select the location of 4, so we look into this location, remember that through the new PTR, and then we try to put the data part into the element to the data part of the new PTR's data location. So again, there's 3 preparation steps coming from those 2 lines of the code. After that, we'll try to look into the locations of what we want to insert. Since top is not equal to null, top originally is already have the A over there is not null, so we will go into the else part, and since the position is equal to 0, now we need to do this 2 line of the code. We make new PTR to the next equals to the top. So new PTR, so you can see that new PTR, originally the top is A, so the top is over here. The new PTR to the next will equals to top. So you can see new PTR next is indicating this box, and then it will equals to the top location. So A will become into this spot. And then once we have done that, we will be able to say top equal to new PTR. So the top will changing from A location to this location. And then that's the 2 line of code required to insert this operation. So that gives you the full picture of what the insert operation is going to do. And therefore, you can see that for the insert operation, the 2 lines is the preparation for the space. Remember that as the new PTR location, and then put the element into the data part. So there's if statements over here. If there's nothing and the position is equal to 0, we will insert the very first item into the linked list. If it is not empty and the position is required to be inserted at the location of 0, this is the 2 lines that we will do. Otherwise, the general case scenarios will be used, and then that's what's happening over the insert operation.